Hello again, everyone. I'm very excited to be chairing this Convergence session on connecting the ocean. We have four exciting talks, and they cover diverse topics in this session about bringing power and connectivity to sense the ocean at scale. Our first speaker is Dr. Julie Jakoboski, who is an oceanographic data scientist at MetOcean Solutions and the team lead of Tiro Moana workstream for the Moana project. So let us please play Julie's video. Thank you.
Hi everyone, my name is Julie Jakoboski, and I am a data scientist and physical oceanographer at MetOcean Solutions, which is a division of the Meteorological Service of New Zealand. And I'm here to talk about the Moana project's Tiro Moana. The Moana project is a New Zealand nationwide project with the goal of revolutionizing ocean observing and modeling in New Zealand in order to support New Zealand's blue economy. And it does this by providing improved ocean forecasts, hindcasts, observations, and it correlates all of that information with traditional ocean knowledge. But the part I'm going to focus on is called Te Tiro Moana, which means eyes on the sea, and that's the ocean observing part of the project. And one of the things that we're trying to do in Te Tiro Moana is fill in gaps of existing ocean observations, particularly below the surface, in order to improve our ocean models. So what's the problem? This is a map of the average number of Argo profiles per day between 2007 and 2017 around New Zealand. Now, for those of you who aren't familiar, Argo floats measure temperature and salinity as they move up and down in the ocean between the surface and about 1,000 meters depth, and they go all over the global ocean doing this. But they don't usually go into coastal regions. So you can see here that we have less than one Argo event per day in all around New Zealand, and we have this big white gap in the coastal regions. So the question is, how do we fill that gap? New Zealand has a massive EEZ, or Exclusive Economic Zone, and in it are about 650 commercial fishing vessels that are operating currently this year. So where are those vessels operating? Well, it turns out they're right in that region where we have a gap in subsurface ocean observations. And this is important for two reasons. First, the fishers care about the temperature in those regions. And second, the fishers happen to be in this region where we have a lack of ocean observations. So if you look at this plot, you can see that the average number of Argo profiles per day around New Zealand is about 3 to 6, and the average number of fishing events per day is somewhere around 300. So this is a massive resource if we can use it. So how are we solving that problem? Well, the Moana project, together with our technology partner Zebra Tech, which is led by John Radford in New Zealand, is developing a temperature and depth sensor called Mangopare. So Mangopare means hammerhead shark, and it was named by the Whakatohea tribe in New Zealand. And the idea is that the sensor is mounted on fishing gear. As soon as it hits the water, it starts measuring temperature and pressure, and it continues measuring until it's retrieved to the vessel. And when the sensor comes above the surface, it transmits its observations of the ocean to a deck box mounted on the vessel, which is solar. That deck box then sends all of its data via satellite or cellular to the cloud, where the data is quality controlled, incorporated into our ocean models. We update our ocean forecasts, and we return that to the fishers so they can understand what's going on below the surface. We're currently trialing the sensors in collaboration with the New Zealand Seafood and Fishing Organizations and with our international collaborations with the Bering Data Collective and Scripps Institution of Oceanography. So the key thing is the sensor requires no intervention by the fishers. So once it's installed on the fishing gear, the sensor has a battery life of 2 years, and it can just continue with operations daily up to 2 years, automatically transmitting its data back to us. And the key thing here is it's in near real time. So we get the data within 24 to 72 hours from when measurements are actually taken, which is important for assimilating observations into our ocean models to produce forecasts. It's super low cost. It's really easy to use. It has a good temperature accuracy to improve our ocean models, and the sampling rate changes depending on what the sensor is doing. You can see some samples of us mounting the sensors on fishing gear around New Zealand. The yellow thing is a tough jacket, which basically protects the sensor when it's in situations where it might experience strong impacts. So this is a sample temperature plot coming from one of the sensors on actual vessel, courtesy of Alan Baslage and his vessel, the Kathleen G. And you can see the deployment of the fishing gear, and then the gear is fishing at depth where it's cooler and then returns to the vessel. So there's a lot of benefits to the seafood sector, but some I'm highlighting here are that it supports their catch optimization, so they can target the species they're supposed to be and avoid the ones that they're not supposed to be fishing that are protected. And it contributes to fisheries management decision making. These are all of our partners. Thank you to all of them. It's a nationwide project. If you have any more questions, please feel free to contact us at info@moanaproject.org or check out the website moanaproject.org. Thank you very much.
Very exciting talk. Thank you very much, Julie. A reminder for those of us watching online, you can ask your question on Slido, and you can upvote questions in order to promote them so that we ask the most upvoted questions.